Welcome back to my YouTube channel GrandpaMathematics. We have seen how to evaluate the integral using the properties of definite integral. Today, let us see how to evaluate the integral as the limit of a sum. Let f of x be a continuous function defined on the closed interval a comma b. Let us assume the function takes only positive values interval a comma b, then the graph of the function is a curve above the x-axis. Now, the definite integral a to b f of x dx is the region bounded by the curve y is f of x, x-axis, and the ordinates x is equal to a and x is equal to b. Now we have to evaluate the area of this region. Now OP is equal to A and OQ is equal to B. So PQ is nothing but B minus A. So we will divide B minus A into n equal subintervals. So B minus A by n, this gives the value of h. H is the width of each subinterval. So, if OP is equal to A, then what is the value of PS? X is A, then PS is nothing but Y. What is Y? Y is X is A means Y is f of A. So, PS is nothing but f of a, and x1 is a plus h. What is this height? Is nothing but x is a plus h. Then you put x is a plus h, y is f of a plus h, f of a plus 2h, f of a plus 3h, and so on. And rs is nothing but f of a plus nh. What is the value of this one? Is nothing but f of a plus n minus 1 times h. We have divided the region P, Q, R, S, P into n sub-regions. Each sub-region is defined by the intervals x0, x1 and x1, x2 and so on. Thus consider the area of the region ABED. This area of this region is greater than the area of the rectangle ABCD and less than the area of the rectangle ABEF. Hence, here we have n subintervals and we are going to have infinite number of subintervals. As n tends to infinity, h tends to 0. So that means x3 minus x2 tends to 0. Then the limiting value of rectangle ABCD is equal to the area of the region ABED is equal to the area of the rectangle ABEF. So we call this as inequality 1. Not this is f of x naught, this is f of x1, this is f of x2, and this value is f of x3. Sn is equal to h into this f of x naught plus again h into f of x1 plus etc etc. The last one h into f of xn minus 1. So this we can write as h into sigma f of xr where r is equal to 0 to n minus 1. What is small sn? Is nothing but the sum of all subregions, all n subregions, by taking the lower limit of the rectangle. Area of the rectangle by taking the lower limit of the rectangle. Similarly, if we take the upper limit of the rectangle, then s suffix n is equal to h into f of x1. For this one, h into f of x2 plus etc. Then h into f of xn. So how we can write this? This is nothing but s suffix n is h into f of xr, r is 1 to n. S suffix n is less than or equal to area of the region P, Q or S P. This is less than or equal to capital S suffix n. As n tends to infinity, h tends to 0, then this becomes a limit h tends to 0. This is equal to, this becomes integral a to b f of x dx, limit h tends to 0 s suffix n, by taking this inequality 1. Area of the region PQ or S P, that is nothing but the integral a to b f of x dx, and that is nothing but h into f of x1 plus h into f of x2 plus etc. h into f of xn, where xn x1 is a plus h, x2 is a plus 2h, and xn is a plus nh. x0, x1 is a plus h, x2 is a plus 2h, and so on. So x suffix n is a plus nh. Therefore, integral a to b f of x dx is equal to limit h tends to 0, h into limit h tends to 0, h into f of a plus h plus f of a plus 2h plus etc. f of a plus nh. This is the definition of the definite integral. Okay, integral a to b x dx is what? So by definition, integral a to b f of x dx is equal to limit h tends to 0, h into f of a plus h plus f of a plus 2h etc. plus f of a plus nh, where h is equal to b minus a by n. So in this problem here, if we compare this with this definition, We get a is equal to a only, b is equal to b only, f of x is x. And h is equal to b minus a by n only. Therefore, integral a to b x dx is equal to limit h tends to 0 h. Here f of x is x. We have to find the value of f of a plus h. F of a plus h is in place of x, a plus h is there. So f of x is x. So f of a plus h is equal to a plus h only. Plus, we have to find f of a plus 2h. F of x is x. In place of x, 2a plus h is there. F of a plus 2h is equal to a plus 2h plus a plus 3h plus etc. Then a plus nh. Now this equal to limit h tends to 0 h into, we'll take all the a's, a plus etc. plus a. This comes n times plus h plus 2h 3h plus etc. plus nh. This becomes na. Here h plus 2h plus 3h is a take h outside. Then 1 plus 2 plus 3 plus etc. plus n is there. We know 1 plus 2 plus 3 etc. up to n. This is nothing but sigma n. That value is equal to n into n plus 1 by 2. Therefore, this value will be n into n plus 1 by 2. We know this value. Sigma n is equal to n into n plus 1 by 2. N will take outside. We have taken n outside. So here becomes a only. Then multiply this hn plus h by 2. Wherever nh is there, put nh is b minus a. So this is equal to limit h tends to 0 b minus a plus b minus a plus h by 2. Now take the limit h tends to 0. So b minus a into a plus b minus a by 2. H tends to 0. B minus a, 2a minus a. So a plus b by 2. This is nothing but b plus a into b minus a. So b square minus a square by 2. So this is the answer. Now we can check the answer. We know that integral a to b x dx is x square by 2 a to b. So b square by 2 minus a square by 2. b square by 2 minus a square by 2. Compare integral 0 to 5 x plus 1 dx with the definition of integral a to b f of x dx. we get here A is equal to 0, B is equal to 5, and H is equal to B minus A, 5 by n, and f of x is x plus 1. Therefore, integral 0 to 5 x plus 1 dx. So this is equal to limit h tends to 0, h f of a plus h. A is 0. So wherever a is there, put 0 now. So it will become f of h plus f of 2h plus f of 3h plus etc. f of nh. Because a is 0, I put a is 0 everywhere. So this equal to limit h tends to 0, h into f of x is x plus 1. What is f of h will come? Is h plus 1 plus f of x is x plus 1, f of 2h is 2h plus 1. This f of 3h is 3h plus 1 plus etc. What will come like f of nh? nh plus 1. F of x is x plus 1. So whatever comes inside the bracket plus 1. Now limit h tends to 0, h into h plus 2h plus 3h plus etc. plus nh. This is one term. Then plus 1 plus 1 plus 1. 1 plus 1 plus etc. How many times? 1, 2, 3, n times. Now take everywhere h outside, then this will become 1 plus 2 plus 3 plus etc. plus n plus n times 1 is n. H into what is 1 plus 2 plus 3 up to n? This is sum up to first n terms. That's nothing but n into n plus 1 by 2. N into n plus 1 by 2 plus n. We know that nh is 5. So wherever possible, bring nh. So here take one n. Here one n is there, here one n is there. Take it outside. So hn. If I take n outside, what will come? Only h into n plus 1 will come. So we'll write nh plus h by 2 plus 1. This n we already taken outside. Now for nh we'll put 5. So limit h tends to 0. So 5 plus h by 2 plus 1. Now take limit h tends to 0, so it will be 5 into 5 by 2 plus 1. 5, h0 means 5 by 2 plus 1, so 7 by 2, so 35 by 2. So this is answer. So 35 by 2. Okay, on comparing this integral with the definition, we get a is equal to 2, b is equal to 3, and h is equal to b minus a by n. So 3 minus 2 by n is equal to 1 by n, and f of x is x square. F of x is x square. Therefore, integral 2 to 3 x square dx is equal to limit h tends to 0 h f of a plus h. A is 2, so we have to replace a by 2 and we have to write. So f of 2 plus h plus f of 2 plus 2h plus f of 2 plus 3h plus etc. plus f of 2 plus nh. F of x is x square. So that means f of x is equal to whatever comes inside the bracket, you have to square that. So f of 2 plus h means 2 plus h comes inside the bracket, we have to square that. So 2 plus h whole square plus 2 plus 2h whole square, 2 plus 3h whole square plus etc. 2 plus nhc whole square. We will expand this. So 2 square 4 plus 2ab 4h plus h square. This is the expansion of the first term plus 4 2ab 8h plus 2h whole square. I am not writing 4h square, I am writing 2h whole square plus n h plus nhc whole square. Now we will take only the first term here, 4, again plus 4, again plus 4, plus etc. plus 4. How many times? 1, 2, 3, n times. Plus, now we will take the second one, 4h, again second one, 8h, 12h, plus etc. 4nh. Then plus h square 2h whole square 3h whole square plus nh whole square. So 1h square, 1h whole square plus 2h whole square plus 3h whole square, like that is written. Now we can take the h square outside, then it will become 1 square plus 2 square plus 3 square form. That's why I have not simplified here. And I have not written 4h square, 9h square like that, because this will come in this form. 1 square plus 2 square plus 3 square plus n square. We know the value of sigma n square. 4 plus 4 plus 4 n times. What will come? 4n plus, in this 4h plus 8h plus 12h plus etc. up to 4nh is there. So we'll take 4h commonly outside. So if we take 4h outside, what will come? 1, 2, 3 plus etc. plus n. 4h if we take outside, n comes. Plus, here we take h square commonly outside. Once we take h square outside, 1 square plus 2 square plus 3 square plus etc. plus n square. For h, now 1 plus 2 plus 3 plus etc. plus n, that is nothing but sigma n. What is the value of sigma n? N into n plus 1 by 2 plus h square into, what is 1 square plus 2 square plus etc. plus n square? That is nothing but sigma n square. What is the value? N into n plus 1 into 2n plus 1 by 6. Sigma n square is n into n plus 1 into 2n plus 1 by 6. N into n plus 1 into 2n plus 1 by 6. Shall we take 1 n outside? We'll take 1 n outside. So nh, then what will come? This will become 4. We have taken 1 n outside. So 4 by 2. So 2 h into n plus 1. We have taken this n outside. So h square into n plus 1 into 2n plus 1 by 6. Four plus, this is 2nh plus 2h h square is there. We will multiply this by h, again this also by h. So nh plus h 2nh plus h by 6. Now we will put the value of nh is equal to 1. So this is 1, 4 plus 2 plus 2h plus 1 plus h two plus h by 6. Now take the limit h is 0. So wherever h is there, put 0. So this will become 6. Then 0, 1 plus h1, 2 plus h2, so it will become 2 by 6. That is nothing but 1 by 3. So answer is 19 by 3. So this is the answer. On comparing this integral with the definition of definite integral, we see a is equal to 1, b is equal to 4, h is b minus a by n, 4 minus 1 by n, 3 by n, and f of x is x square minus x. Now integral 1 to 4 x square minus x dx, this is equal to limit h tends to 0 h. So limit h tends to 0 h, f of a plus h, a is 1. So first we will replace a by 1 and we can write so f of a plus h is a is 1, f of 1 plus h. Now f of 1 plus h is what? F of x is x square minus x. So that means we have to see this way, f of x is equal to square of whatever comes inside the bracket minus whatever comes inside the bracket. So square of whatever comes inside the bracket minus whatever comes inside the bracket. So here what comes inside the bracket? 1 plus h. Square of whatever comes inside the bracket, that is 1 plus h whole square minus 1 plus h plus this is for the first term. We should not simplify. I will tell you the reason why. So this equal to again 1 plus 2h whole square minus 1 plus 2h. Now because 1 plus h whole square is there and minus of 1 plus h, 1 plus 2h whole square is a minus 1 of 1 plus 2h, like that. So we will expand this. We will simplify this term. 1 plus 2h plus h square, then minus 1 minus h. This is after simplifying the term, plus 1 plus 4h plus 2h square minus 1 minus 2h plus 1 plus 6h plus 3h whole square minus 1 minus 3h plus etc. 1 plus 2nh plus nh whole square minus 1 minus nh. So 1 minus 1, 1 minus 1, 1 minus 1, 1 minus 1 is there, so that it gets cancelled. Then 2h minus h, then 4h minus 2h, 6h minus 3h. So we will take this, so this already we taken. So we take the h term now. 2h minus h is h, 4h minus 2h is 2h. 6h minus 3h is 3h plus etc. 2nh minus nh, that is nh. So we consider this term, this only h square term is there now, plus h square two h whole square plus 3h whole square plus etc. plus nh whole square. In this term, everywhere h is there, h plus 2h plus 3h is there. Take h commonly outside. So h into 1 plus 2 plus 3 plus etc. plus n plus, now take h square outside. Then we'll get 1 square plus 2 square plus 3 square plus etc. plus n square. We know that this value will be n into n plus 1 by 2 h square into, what is this value? N into n plus 1 into 2n plus 1 by 6. We have to remember this formula. Sigma n is equal to n into n plus 1 by 2. Sigma n square is equal to n into n plus 1 into 2n plus 1 by 6. Now, what is the value of nh? nh is 3. So, wherever take one n outside, then multiply this by h. So, nh plus h by 2. Here this n we already taken outside. We'll multiply this by 1h and this by another h. So it will be nh plus h. This will be 2nh plus h by 6. Now for nh, we'll put the value 3. So 3 plus h by 2, 3 plus h into 2 into 3, 6 plus h by 6. Now put h is 0. So we'll get 3 into 3 by 2 plus 3 into 9 by 2 is equal to 27 by 2. So this is the answer. On comparing this integral with the definition of definite integral, we get limit h tends to 0, h a is what? Minus 1. So wherever a is there, put minus 1. So f of minus 1 plus h. What is f of x? E power x. So f of x means f of x is e power x. So this is equal to e power whatever comes inside the bracket we have to write. So inside the bracket minus 1 plus h is there. So e power whatever comes inside the bracket minus 1 plus h. Then e power minus 1 plus 2h. So e power minus 1 plus h we can write as e power minus 1 into e power h, e power minus 1 into e power 2h. E power minus 1 will take it outside the bracket. Then this will become e power h. E power 2h we can write as e power h whole square. Then e power 3h is e power h cube plus etc. e power h power n. So limit h tends to 0, h by e. So this is a GP with the first term e power h and common ratio again e power h. What is the sum up to n terms of a GP? That is nothing but a into r power n minus 1 by r minus 1. Where a is the first term, here first term is EH and r is the common ratio. EH into EH is EH square. So r is EH. So you can write e power h into r power n, e power h power n minus 1 by e power h minus 1. nh value is 2. nh value is 2. So we know limit h tends to 0, e power h minus 1 by h. So this is equal to 1. Limit h tends to 0, e power h minus 1 by h is equal to 1. So we will e power h minus 1, this h will bring it down, so that will become 1. So limit h tends to 0, 1 by e, then e power h, e power nh minus 1 by limit h tends to 0, e power h minus 1 by h. So this h I have taken to the below this e power h minus 1 by. Now this value becomes 1. Now take put the value of h is 0. Limit h tends to 0. So 0, e power 0 is 1. So 1 by e into e square minus 1. So we can write this as e minus 1 by e or e minus e power minus 1. So this is the answer.